Okay, now I want to talk about banked curves. What is a banked curve? Why do we use it? Banking is done on roads, especially when there are big turnings, right? So what you do is you try to bank your curve so that the circle that you're going around helps you stay in a curve. Because what your car wants to do is do the tangential thing, right? You're trying to get your car to come in, but the car wants to go. Inertia makes it want to go straight. So you're trying to force your car to come around the curve. And so you bank it to help your car go straight forward. And so now let's derive an expression on how fast you could go with what banking, right? So we're going to try to figure out the banking angle. Ready? Okay. So what is a banked curve? So here's my car. The car is going straight forward. Okay, it's going into the paper. Now, here's the question. Where is the centripetal force in this case? So this car is going around in a circle like this. And we are trying to bank it so that it comes back. Where will the centripetal force act?
Down the slope?
No, that's the mistake that everybody makes. It doesn't matter for the centripetal force how much it is banked. It always points towards the center. And that is a good point. It's because this is a common mistake that we all make. You are right. We should assume that it will go towards down the slope, but it doesn't. What it does is it actually goes towards the center of whatever the curvature you're going at. So your centripetal force goes inwards. Now, where will your friction go? Yes?
It's going to go, the car is trying to escape.
That's right. So even though the car is moving forward, there is also a friction that's moving back and forth. But in this particular case, we only care about the friction that is causing the car to stay on the curve. Got it? Friction is what is opposing the motion. Always. Where does the car want to go? Right? Out of the curve. So where will friction work? In towards the center. So if I'm going to draw the friction, will my frictional force be here? And then there's one force that always acts, which is the weight, gravity. And then there's another force that always acts because the car is sitting. Goes up. Now we have a choice. And suppose this angle is theta. What do you want to use as your coordinate system? You have two choices. You can either choose this one to be your coordinate system, or you can choose this one to be your coordinate system. There are advantages and disadvantages to both of them. I tend to use this one, and the reason is because I really cannot know where the flat ground is physically. Like I'm a very sort of like, I want to know why things are happening. I can see the slope because I'm standing on it. I really don't know where this one is with respect to the slope. So I tend not to choose this one. I am not saying you should not use this one. Go ahead and use that one, but I tend to avoid using it. Make sense? And also the advantage of using this system is that I have very few other forces I have to worry about dividing the coordinates for. Okay? And for most of them, they remain the same. So for example, I chose this X and Y to be my coordinate system. Actually, we could flip them and use the X, Y the other way around too. Anyone want to do that?
Nah.
No? I mean, we could. Doesn't matter. What forces do I now have to divide the coordinates in? Well, N is along Y, so that's good. MG is not along either of them, so I have to divide that. And MG is easy to do. It's always the same. Where is the angle? That one. So this will be MG, and this will be MG. You can close your eyes and you can draw them. And note very carefully, make sure you draw the lines. Right? It's always head to tail rule. You should know where these arrows go. Now, another force that's in here is friction. Is friction okay? Is it along the X or the Y? What's it along?
Thanks.
So we don't do anything to it. But we'll look at what happens to the centripetal force. It's not along X or Y, so what do we have to do to that?
Sine cosine.
And here's the easy part. What is this angle? The same angle. So that theta and that theta and that theta are the same angles. Got it? So all three of these thetas, this one, and that one are all the same. Get rid of my check marks. And so,
Question.
yeah.
That theta angle is the same as the theta angle in the incline because the centripetal force would almost be parallel to like that ground color, correct?
Yeah, and then the angles don't change. And you could do this where you could flip this triangle over, it'll form the same triangle. That's geometry, right? So this is parallel. So these are two parallel lines, right?
Yeah.
And then this is a line and this is a line. If this is a theta, what will this be?
Yeah.
Right? So this is basic geometry. Yep, it flips over. Because these two can be combined together. I can redraw this and move it closer to here.
Yeah.
Mhm. So now we have all our forces and all our components. What's the next thing we do in Newton's laws? Always. Okay, so anybody want to tell me what to write for sigma fx?
Sigma fx equals
F, okay. F will be plus or minus.
M
Oh, mg.
plus
Okay, this will be plus.
F plus FC.
Nope, fc never goes on that side. Fc is the resulting, right?
No, centripetal. Oh, it is. Yes.
So remember, this can be either ma or 0 or mv squared over r.
Right.
This is when it's moving in a straight line, this is when it's 0, and this is when it's in a circle. So Fc will never go on the right side because it's not a force that's actually acting on the object.
It's the result.
It's the resultant of it, right? So always remember these are our three options, and they always go to the left side. That is a good point, and that's easily confused. Don't confuse that.
Right. Thank you.
Yep. No, that's a good point. Thank you for making it. Okay, now what about sigma Fy? Somebody else. Who wants to take it? Okay, Amanda.
You're gonna have the normal force positive.
Okay.
You're gonna have mg cosine theta.
Plus n minus mg cosine theta. Does everybody agree with that? Okay, now what will sigma Fx be?
Fc cosine theta. Well, mv squared.
And what would sigma Fy be?
Mv squared over r sine theta.
Do you see how that has changed? We are usually used to putting sigma Fy equals 0 and be done. Can't do that anymore because now the resultant force actually has components. Okay, well then this is going to be mu n, right? And I know this will give me mv squared over r sine theta plus mg cosine theta equals n. mv squared over r cosine theta equals mu n plus mg sine theta. Call this 1, call this 2, plug this value in here. What will I get? So from equation 1, let me give myself more room. So from equation 1, may I write mv squared over r cosine theta equals mu mv squared over r sine theta plus mg cosine theta plus mg sine theta. Okay, may I move mv squared over r together, cosine theta minus mu sine theta equals mg mu cosine theta plus sine theta. Guys, watch what happens. The mass of the car becomes irrelevant. This is amazing. So a truck, an 18-wheeler, mini compact, everybody can be going and you can get a same speed for everybody. That is the magic of physics. It's independent. That's so cool. Anyway, RG mu cosine theta plus sine theta divided by cosine theta minus mu sine theta. We can get rid of that to give me that. Okay, now what if I don't have a friction? What if it's magically a frictionless case? Mu goes away, what are we left with? RG. Yes? Because this will go away,
Oh,
and then this will go away. Woohoo! Wow.